Okay, so we are going to do test of hypothesis using R. We have already learned the theory, most of the theory. So here I am working with the faraway package, and I will illustrate a number of ways using which you can carry out hypothesis testing using linear models. So what I first do is I load the package faraway, and I am going to use the data set called GALA for Galapagos. It has various things: species, endemics, area, elevation, nearest, cruise, and adjacent. Now I am going to fit a model. So this particular example is taken from the book, so I am just imitating their thing. You can find it in chapter 3. So what I will do is I will fit a linear model on the response variable species on everything except the endemics variable. So I can write it, instead of listing all the things, I can just write it by putting that dot minus endemics, the way I have done. So I will fit that model, and then I want to see whether area, that regressor area, is of any importance or not. So I will fit a model without that thing also. So I have got the two models: the general model fit, which I assume is a correct fit, is a good fit, and fit not, which is a restricted model. Now I can do those things: RSS not, minus RSS, etc., etc. Now R already has a built-in feature for doing that thing for us. It is called anova. So this function anova will do this thing for us, anova function. And if I write it in this way, so first I will write the restricted model, and then I will write the general model. So the restricted model followed by the general model, and I just execute it. You will get this output. It has the degrees of freedom and the two RSS. It also says what are the two models, the model 1 and model 2. So in the first model, this is somewhat badly written. It says that everything minus endemics, and in the second thing it lists everything, then subtracts in. Okay, so model 1 is the restricted model and model 2 is the general model, and it will carry out the thing. So this one is your RSS naught minus RSS, and this is the difference in the degrees of freedom, and they are dividing it by the appropriate thing. So they are getting this F statistic and the corresponding p value of the F statistic, which is the probability that you will exceed this observed value if the null hypothesis is true. Since the p value here is, say, greater than 0.05, I will say that I am accepting the null hypothesis. So in this case I say that yes, you can drop area and the fit will not be much worse for that. Now this ANOVA function is a kind of stupid function. So if you do the following thing, that is, you write the general model first and the restricted model next, the ANOVA function doesn't object, and it just produces something very weird. It produces a negative degree of freedom, and the sum of square turns out to be negative. However, when it computes the F statistic, it takes the absolute value, which is also a weird thing to do. So eventually it gives you the correct answer when you look at the F statistic or the p value. But just remember that you have to specify the restricted model first, the null model first, and the general model next.